Welcome to Lyceric Papers. Today I want to unravel or explain the vacuum permeability using the second electromagnetic wave theory that I've created. For those that recently viewed my fine structure constant video, they can skip the next couple of slides because this refresher is just a repeat. For those that are new here, you can also go either to that fine structure constant video, or there are more detailed videos on my channel that explain the theory in detail. But fundamentally what we're talking about here is that there are two electromagnetic waves. One is the well-known oscillating electromagnetic field that propagates through space, and the second one is an electromagnetic wave that is made out of small charged particles, which I call attons, that originate typically from the electron. So the electron is made up out of these small charged particles, and the structure is 2/3 negative attons and 1/3 positive attons. The antimatter positron is, of course, then the opposite. It is 2/3 positive attons and 1/3 negative attons. So as the spinning electron is jolted, the upper layers of the electrons start unraveling, and because they already have the circular momentum, they start creating their own magnetic field, and this magnetic field sustains this helix coil as shown here, and this helix coil then propagates through space. Fundamentally, if it doesn't get hit by another light wave, it will continue on forever and ever. I have to, though, add if it doesn't also hit too much dark matter. But anyway, the key here is that there is a balance between the centrifugal force and the charge force. And the charge force then creates this field, and the more charges there are on this wave, the stronger the field gets, and of course that results in a higher frequency because there are more charges on that helix and more particles, and also that would then reduce the wavelength. So now going back to the fundamental idea that there are 2/3, 1/3, 2/3 negative attons and 1/3 positive attons. Of course, you then get a helix where both negative and positive particles are flying. And the difference is they fly in the same x direction, but they have a counterclockwise and clockwise direction. So the one flies clockwise, the other one flies counterclockwise to create a field in the same direction. On the picture here on the right-hand side, you can also see kind of the structure, which shows how you create this 1/3, 2/3 structure that creates a very firm, strong structure using this 1/3, 2/3 principle. So, having explained that, and again, please, go to my other videos and look at the details there. But go back to our actual topic is the maximum frequency of the second electromagnetic wave and how it actually pertains to the vacuum permeability. So if we look at picture 3, which shows the light helix approaching the observer, then you can see that picture 4 is the same light wave with the smallest possible wavelength, which then of course is the highest possible frequency. The interesting part of picture 4 is that because of the size of the Atton, that circular motion cannot be smaller, so you cannot create a smaller wavelength than the two Attons. And you need two Attons. So fundamentally, the wavelength the radius of the wavelength, which is half the wavelength, is basically then the diameter of the atom. And I think this is the crucial understanding for the next slide. So the next slide, we actually now calculate both the minimum wavelength and thus also the diameter of the atom. And we then, of course, naturally can quickly calculate the maximum frequency. So again, these particles are flying and are held in equilibrium because the mass, the centrifugal force, the force of the mass, is held in equilibrium through the force of the charge. So then you can dissolve this formula in accordance to c square, and then you can c square, of course, is 1 divided by the permittivity and the permeability constant, and then that quickly creates the formula 1. You can then rearrange formula 1 so that you then step by step can create the value of the minimum wavelength, which is then the diameter of the atom, which comes out to be 2.3536 10 to the minus 23 meters. And that leads to the maximum frequency of a photon, or this helix coil flying through space, to 1.27 10 to the power of 30, sorry for the typo there, 10 to the power of 30 hertz. So having done that, we then have to understand what is actually the vacuum permeability constant. So basically, if you look at it really closely, it is the maximum electrostatic force, because it is the minimum distance from each other, to the mass of the Atton ratio. So that's kind of the key here, is we're looking at the maximum electrostatic force that can be exerted because of the geometric distance. And this, interestingly, also gives us the diameter of the atom, which will be very important for us to determine the structures of the particles. That this result is correct, or very close to being correct, is that the highest recorded gamma photon was recorded out of the Crab Nebula at a frequency of 2.42 10 to the power of 28. And that's about 50 times smaller than the maximum theoretical frequency of this second electromagnetic wave, or if we want to get used to photon, the second electromagnetic wave photon, which is in reality a helix coil. So you might, get closer to it, like 20 times lower, but I think the Crab Nebula gamma ray probably is about the max frequency in all reality that we achieve in practical sense. So I think this is going to be very important for the next video to show that the number that we arrived at, the number that relates to the diameter of the atom, is correct. And to do that, we're going to need some really good measurement. And I think one of the best measurements of a particle is the measurement of a proton. And over the last 10 years, the measurements have pretty much come together to one measurement, except for the so-called muon measurement. But that gives us a strong reference point that we're going to use to show that the number that we came up with has full merit. So things are getting exciting. I'm seeing a lot of numbers matching up now. and I see how this whole thing really works really easily. So I would welcome you to the next video and hope you had some interesting time watching this. Thank you very much. Hope to see you soon.